Good afternoon once again. We're back now with our ELaNa CubeSat briefing. CubeSat's also on our Delta II rocket to be launched on Friday morning. And here to discuss the CubeSats and their mission is Garrett Scrobot, the ELaNa Mission Manager from the NASA Launch Services Program at the Kennedy Space Center, and Roland Coelho, the P-Pod Program Lead from the California Polytechnic State University in San Luis Obispo, California. And we'll begin first with our mission manager, Garrett Scrobot. Garrett?
Thank you, George. Good afternoon, everyone, and glad you can make it out. What an incredible opportunity we have on Friday morning to be able to launch ELaNa 3. ELaNa is educational launch of NATO satellite. This is our third in the series we have right now. We look at it from the point of we're enhancing education through spaceflight. The mission has 6 CubeSats, of which there are 5 missions. And if we go to the first slide, that's actually the second slide, but we'll go ahead and talk to it. All right. Okay, go ahead and go back to the previous slide. One of NASA's missions and goals is to be able to retain students in the mathematics, science, mathematics, engineering disciplines. And through the CubeSat projects, we were able to create a program to incentivize students, strengthen NASA and the resources. To do this ELaNa program, we had what we developed the CubeSat initiative. To date, there's been 2 calls for CubeSats throughout the educational community and nonprofits, and the third one is currently on the streets, and the proposals are due in November 14th. From these calls, we've received 32 CubeSat missions have been selected to fly so far, and of these 32, we have 26 manifested, and a part of these are on the MPP mission, the ELaNa 3. I put together this graphic here of the United States, basically showing the states where the ELaNa project has touched to CubeSats being developed and has been selected. Currently, there's 18, and we're hoping to be able to one day have this whole map completely filled out. The next chart. Next slide, please. Here's our mission patch, ELaNa 3. We have, like I said, we have 5 missions on board. Montana, E1 Prime, AubiSat from University of Auburn University, M-Cubed from Michigan, University of Michigan. RAX-2 will also be from the University of Michigan, and DICE from Utah State University. None of this could be possible without Cal Poly and the Poly Pico orbital deployer, and there are the CubeSats will be fitted into, and we'll show you that in a little bit. So, and here we have our patch indicating education launch of NATO satellite. So, if we go to the next image, well, that was the first image we talked about, but this is where we talk. I'll go ahead and go back. We'll talk to it anyway. This right here basically showing the international, the national concept of being able to go out and recruit students working on the cubes themselves, maintaining the science, technology, engineering, and launching a key element is launching education into space for these students and giving a hands-on experience flying, touching, and actually building flight hardware for upcoming missions, which really makes them a key entity going into the aerospace workforce. So now if we go to the next image, we'll take a look at some of the students here up at Cal Poly actually integrating the ELaNa 3 missions. You see the P-Pod there on the lower right-hand corner, fully integrated, and up above is the 3 cubes right before going in. With any other project, the students act just like system engineers. They do testing, they verify, they check, and they ensure that everything is proper before it goes into gets mounted to the vehicle. So we go into the next image. The ELaNa 3 mission is going to be flying up on the second stage of the Delta II vehicle here. It's enclosed into the payload fairing. This first image shows the Delta II. This is what it'll be looking like on Friday morning, and then down on the second stage there on the struts, and then we blow it up with the 3 P-Pods on the next image up there in the upper right-hand corner. So we go to the next one. We show where the actual ULA engineer is actually installing the P-Pods onto the vehicle here. We show the P-Pod number 3 with DICE and P-Pod number 1 with E1 Prime Flight 2, AlbiSat, and MCubeCo, and then P-Pod number 2 over there by itself on the other side of the vehicle is RAX 2. So if we go to the next image, this is just a layout of the flight profile of the first two orbits once the P-pods separate, approximately about 1 minute and 38 seconds after T0. Along this flight path, you'll see we start seeing circles around South Africa and Europe. We have a whole network of student ground stations throughout the world that will be collecting data to determine the liveness of the spacecraft, the CubeSats, as they fly around the Earth to make sure we get health. And so when the primary station starts commanding, they know they're ready to go. Thank you there. So, another part of the ELaNa project is there's been a continuing challenge for students to fly spacecraft of this type. And in the past, the CubeSats have been built by many universities across America, and they've been sitting on the shelf. The ELaNa program has now given the Cubes opportunities on a continual basis to fly. Right now, this is ELaNa 3. Currently, ELaNa 4, 5, and 6 are already manifested on the books, and we'll be flying those out through 2012 and 13. So when the engines light up on Friday morning, hundreds of students across America will be ready, sitting at ground stations all around the world, waiting for the first indication of separation and the first data, and being able to get the science down for the different organizations. I do want to make a couple notes here that this is a very unique mission compared to the ELaNa 1 we flew back March. We're in partnership with the National Science Foundation on this mission, the Jet Propulsion Laboratory, SRI, and Astrium are also part of our partners on this, and it's very unique. A couple thank yous that I'd like to throw out there is our LSP management team. They've been very supportive and believed in the ELaNa project and has moved forward, and also a deep appreciation to the MPP project for allowing us to hitch a ride on their vehicle. So thank you.
Thank you, Garrett. And now to Roland Coelho, the P-Pod program lead from the California Polytechnic State University in San Luis Obispo. Roland.
Thanks, George. Thanks, Garrett. So this is my first press conference. It's extremely exciting. I'm probably smiling from ear to ear right now. This is an amazing opportunity that NASA has given to us, to the students. And just wanted to give a brief overview of the CubeSat program. It started in 1999. So we've been at this for about 12 years now. And the original goal of the CubeSat program and the CubeSat standard was to give students access to space, routine, affordable access. And prior to that, it really wasn't there. And so it all started with Bob Twiggs and Dr. Jordi Puig-Suari came up with the idea. Concept came, believe it or not, from a Beanie Baby box. They had the size of the box, and actually this is a satellite. This is a CubeSat. It's a 1U. When was the last time have you ever had a real satellite at a press conference before? Real scale. So they figured out that they could get about 1 watt on-orbit average power with a 1U. COTS components, you can get them offline. Something very easy and simple that students can go ahead and build these satellites. So currently we have over 150 CubeSat developers worldwide. It's truly global. And so we're working with international partners to launch their satellites. And here in the U.S., it's really been Garrett, and his group here launching U.S. universities. So these CubeSats get integrated into the Poly Picosatellite Orbital Deployer, or P-Pod, built by Cal Poly, which is this you can see here. This is full scale. This mounts to the V-struts on the Delta II upper stage. We will be showing you guys a video of CubeSat integration actually at Cal Poly in a little bit. But this P-Pod was developed to protect the launch vehicle and the primary payload. I mean, that was the big intent. Deploying CubeSats and getting them into space was secondary, but really we had to show the U.S. launch community that we put the launch vehicle and the primary payloads first to reduce as much risk as possible. And so one of the interesting stories about the sizing of the P-Pod actually came from a Delta II launch vehicle. it was about 99, 2000. We were developing the P-Pod, and we actually went out and looked at all of the launch vehicle accommodations out there. Delta II was one of the only ones that actually had a secondary payload accommodation in their user's guide. So you can actually fit 3 of these CubeSats into the P-Pod, and the length of this P-Pod is actually about the length of the Delta II secondary payload accommodations. And so that's where the form factor came about. And so over the years, over the last 12 years, ELaNa 3 is our 10th launch. It's exciting for us at Cal Poly because we finally made it to the Delta II and to prominent U.S. launch vehicles. This is a huge step. We originally started out with the Russians. We had 3 launches with them first, and then we started working towards getting the P-Pods and CubeSats on U.S. launch vehicles. And so we've kind of come full circle in terms of starting off as a student project, going with the Russians, and now we're launching it in our own backyard. It's absolutely amazing. And so one of the things, I just wanted to tell you guys a brief story of how I met Garrett. I was about 21 years old, went to the Small Payloads Rideshare conference about 6 or 7 years ago, and I pretty much knew nothing. Our advisor, Jody Putswari, said, go to Denver, go to the conference, have fun, but get us launches on U.S. vehicles. It was a pretty daunting task. I had no idea what I was getting myself into. And so actually talking to people at the conference, a bunch of people said, you see that gentleman over there? His name's Big Daddy. You have to talk to him. And he's a NASA mission manager. And, I was scared to death to approach him. But I started talking with him, and we had an amazing conversation at the workshop. He basically said that continue with the launches, get flight heritage, but be patient. It will come one day. And that was 6, 7 years ago. And, 6, 7 years, till now, it's an amazing experience. We're finally here. We have something sustainable. And Garrett, the biggest heart in the world, he kept his promise, and, and here we are today. Also, to the tremendous impact the ELaNa program has had on the CubeSat community and the students at Cal Poly is absolutely tremendous. I think one of the big things that may be lacking in some of the education that we get in the classroom is we don't get this real world experience. We don't get real engineering problems we have to solve. And so if you fail a test, you get an F. If you fail problems or if you can't resolve issues, you don't go on the mission. Mission's over, and the impact is much widespread. And so the ability to work with NASA and for the students to understand systems engineering, to work with multiple disciplines, with mechanical engineers, electrical engineers, computer science, physicists, is a tremendous opportunity. And it's very difficult to find that, to find that in the classroom. And so that's what the CubeSat program gives, and that's what NASA is allowing us to do, is to really have all of these students come together, build a real spacecraft, get it launched, and operate it on orbit. So some of the students, at Cal Poly, tremendous opportunities for them because those students get to work with Garrett and his team on a daily basis. We understand what requirements are. We understand what verifications are. And so when they graduate, they move directly into their job knowing full well what they need to do. And finally, just wanted to thank everybody, the NASA headquarters, Jason and Ann, NASA LSP, from James Wood to Amanda to Garrett, and to Bill and Larry. It's been a tremendous opportunity to work with everybody, and just want to thank everybody for working through some of the issues that we've had, through these 2 ELaNa missions, never giving up on us, always saying there is an answer, there is a solution, we just need to go work it. And that is amazing. So thank you.
Thank you, Roland. And now we have a feature coming up for you, and we're going to let Garrett tell us a little bit about what we're going to see in a moment. Garrett?
Okay. Some of the research directors and principal investigators from the ELaNa 3 mission took a little bit of time out this week and put together a video describing a little bit about the CubeSats and some of the science and what they're doing at their home universities. And so we just want to show that video now.
The name of the CubeSat is Radio Aurora Explorer. It's a ground-to-space bistatic radar experiment. So our mission is unique because we get to use very narrow beam, very strong radars that gives us very high resolution measurements of this turbulence in altitude. And at the same time, as the spacecraft flies over the experimental zone, we get very different views of the turbulence with respect to the magnetic field lines. We have 2 websites, one at SRI International and one at University of Michigan. The SRI site provides information about the science operations, ground-based radar operations, and also presents data that are immediately after the experiment. The Michigan website
are unique in bringing together students of different academic background: engineering, physics, power system, communication. Folks who wouldn't normally be seen in the same room together are having to pool their energies to carry out a CubeSat mission. And because they're doing that, the students can then go forward and claim to their prospective employers that they have a lot of interdisciplinary information. In particular, this RAX-2 CubeSat is supported by the National Science Foundation, and the data from it will be available to students decades from now. This is an exciting time for all of us. CubeSats are flying on a yearly basis, and at our research institution, we're working on a variety of remote sensing instruments and payloads that can go on future CubeSats. And we look forward to the day when there's not 1 or 2 going up per year for research purposes, but there's maybe a dozen.
The name of our CubeSat is Dynamic Ionosphere CubeSat Experiment, or DICE for short. And what DICE is going to do is it's going to look at storms in the ionosphere that occur periodically, especially over the United States. So this is especially interesting because it's a US experiment looking at a uniquely US phenomenon. And these storms occur and they can disrupt systems like GPS, navigation systems, communication systems, and surveillance systems. And the ionosphere affects radio communications at all frequencies, and so it's very important that we understand what's going on in the ionosphere. There were 23 students involved over 2 years at Utah State University, and they mostly worked at the Space Dynamics Lab, which is the engineering, spacecraft engineering part of Utah State University. And they were involved in building the instruments, building the satellite. They also helped in the design. So they did mathematical studies of the heat transfer within the satellite, the operation of various components, and they helped to design it. And they provided $1.2 million of funding. But in addition, there's been support from NASA through the Wallops Island ground-based tracking station and the ELaNa program, to which we're very grateful for that help, and the ELaNa program at astraspace.net. And we also have phone apps that are developed by Astra, and we'll be putting some of the data and some of the information on our phone apps.
Name of our CubeSat is OBISat-1. It's named after our mascot at the university, Obi. And it's going to mostly look at 2 encapsulates we put on solar panels and see how well they protect the solar panels from the harsh environment of space. I think what makes it unique is how many undergraduate students have worked on it. Over the years, we've had over 100, probably 200 undergraduate students work on it. No grad students, no professors directly involved. It's a complete undergraduate effort. The end result is that, well, hundreds of students went through a project which is NASA funded and which is also NASA inspired, and they have learned a number of skills which they couldn't develop in the classroom. These are skills of communication, of learning management, learning systems engineering, and not book learning, if you want, but it really is learning by doing. We have approached the international amateur radio community and told them about our satellite. We have to just give them now the Keplerian elements so they know where to look for it and when. And they know the kind of messages they're supposed to hear. And then what they do is they email them to us and tell us what they heard and where they were located, etc. So we're going to hopefully get the news from our satellites from all over the world. The public can participate by logging on to our website, space.auburn.edu. And they're going to find the instructions on how to download the data and also where the satellite will be and when.
The name of our CubeSat is M-Cubed. It stands for Michigan Multipurpose Minisat. And the CubeSat is developed by the University of Michigan. It has a camera on board that will take medium resolution images of the Earth. And then there's a secondary payload on this CubeSat that was developed by NASA JPL. And that payload will do some image processing. Well, what's unique about this mission is, I think, the collaboration that was established between Michigan and JPL to develop a secondary payload. And roughly a year ago, we started this effort through funding from the Earth Science Technology Office. And through the collaboration, we will be validating hardware and a software algorithm for a future instrument that is being developed by NASA for in support of the Decadal Survey mission. Over the course of the entire project, there were roughly 50 students involved at the university. In this last year of concentrated effort with NASA JPL, the core team was about 10 students, and we had roughly 6 part-time professionals at JPL also supporting the payload development. They did all the hands-on work development for this CubeSat. They did machining for the structure, they developed the subsystems, built their own hardware. I think the experience of developing these CubeSats at the university is very important. We really look for that direct experience in our early career hire program at JPL. It's been very interesting to see these students coming through the programs with their hands-on experience. The public can participate in this mission through the amateur satellite community, where the ham radio frequencies for M-Cubed will be made known, and they can track the data. As well as at the university website, umcube.org, we will have results of the mission posted there.
Our satellite is called Explorer 1 Prime. It's named after the United States' first satellite, Explorer 1, that discovered the Van Allen radiation belts in 1958. Our satellite is carrying one of Van Allen's Geiger counters that was used to discover radiation around the planets, and it was donated to us by Dr. Van Allen before he passed away about 5 years ago. Our students began working on Explorer 1 Prime in 2006, and we've had about 125 students involved in the program during these 5 years. Oftentimes, students only have the opportunity to do a design or a concept study. And it's my experience that what really makes the difference is when the students are allowed to actually build their designs, test them, and discover that they don't really work. And then they have to go back and do a redesign and then retest. And this whole process of qualifying a satellite, no matter what its size is for space flight, is where the rubber really meets the road in terms of the learning process. We hope that our satellite will keep on ticking for about 4 months, which would equal the lifetime of the original Explorer 1 satellite. We're currently building 2 other satellite programs, one for National Science Foundation, a scientific experiment to study radiation belts, and a second one under the University NanoSat program for the Air Force Research Laboratories. we believe that the real utility of these very diminutive satellites is in the ability to launch large constellations, dozens of satellites working together in this very small form factor to do things that we've never been able to do in space in the past.
All right, we're ready now to take questions. So please give your name and affiliation again when the mic comes to you, and we'll start right over here with Nora.
Hi, Nora Wallace, Santa Barbara News Press. Do you have any idea how many students might be coming to the launch? And also, can you give us any sense of the collective cost of the satellites on this rocket?
I know that some of the universities are not able to bring the students due to their class schedules, but from what I'm hearing, there's probably 30 to 50 students that's be in the area for the mission, but most of them will be watching it on television, on the webcast back in the at the university dorms, or getting ready for it. As to the cost, every one of them, I believe, is a little bit different. They all cost in a different aspect. One's like DICE, like I indicated, was like $1.2 million for that because it's doing some significant science, where you may have ELaNa or one of the other ones that has just a very smaller science to be a lot less. So.
Janine Scully, Santa Maria Times, Lompoc Record. Well, you mentioned some future missions. What vehicles and will those fly on? And do you know approximately what time frame?
Yes, ELaNa 6 will be flying in July of 2012. We have 3 P-pods with CubeSats on it, and we're partnering with the NRO on one of their missions. After that, we have CRS 2 and 3 flight out of Kennedy, scheduled for late 12, early 13. And we have 4 pods on CRS-2 and 5 P-pods on CRS-3 currently.
Any other questions? Nora?
At this point, is it long enough in the program that you're starting to see students come to NASA and JPL and everywhere else looking for jobs that have worked on some of these? Case in point.
Absolutely. And a lot of the students who graduate are now working, for these companies, and they're coming back to us with CubeSat ideas, collaboration. We see it all the time in government agencies like NASA, also commercial. I would want to say like the CubeSat mafia is slowly starting to spread, and it's amazing to see that the passion's still in them, that they want to come back and help support their university.
There's actually, I believe, one of the students from Cal Poly that's supporting MPP. So I was talking to him at the hotel the other evening.
All right, we have no other questions, none from other centers or online. So that is going to conclude this briefing, and our next activity will be launch coverage, which will begin at 12:01 a.m. Pacific time on Friday morning. Thank you.